My name is John Reese, and I will be giving an overview of the rules pattern. This isn't a pattern that you'd find in your typical design patterns book, such as the Gang of Four, but it's a pattern that I found myself using fairly frequently in programs that I've written. The rules pattern involves identifying areas of frequent change in your application, typical with lots of complexity, and replacing that complexity with a collection of objects that represent business rules. Let's begin with describing the problem the pattern is designed to address with a motivating example. In the case of the rules pattern, the typical problem we're trying to address is growing complexity in a particular area of our application. We have a class, or method, with very complex business logic, and we believe, based on past history or information we have about the future, that additional changes to this area of the code base are likely. Some examples of these kinds of business logic include customer discount calculations, achievement systems for badge or points, and ratings for credit or insurance agencies, just to name a few. We should also keep the solid design principles in mind. You'll notice that if we wish to add a new condition to the check system method on the right, we need to add another if statement within the method. This is a direct violation of the open-close principle. You may also notice that this method is breaking the single responsibility principle. It's doing way more than one thing. The intent of the rules pattern is to separate the logic and execution of individual rules from the logic that processes these rules. The end goal is to allow new rules to be added without the need for changes to the rest of the system. This goal closely aligns with the open-close principle. The open-close principle states that software entities, classes, methods, functions, etc. should be open to extension, but closed to modification. What that means is we should be able to change the behavior of the system without having to change the code itself. With the check system example that we just saw, we were only able to extend the behavior of the code by directly modifying its structure. Clearly, it does not follow the open-close principle. The example also broke the single responsibility principle, which states that a class or method should only have one reason to change. The reason why we want to separate out individual rules from the rules processing logic is that these are separate concerns. If we change how we process rules in general, that should go in a rules processing class or method. However, if we change the individual behavior of a particular rule, either how it chooses to select something or the action that it takes once it's selected, these should go inside of the rules class. So by separating out individual rules into their own classes and having a rules engine responsible for processing these rules, we're applying the single responsibility principle to our system. So let's briefly talk about when the rules pattern should be applied. You should consider using the rules pattern when you have a system that is suffering from conditional complexity and additional changes of the same nature are anticipated. If you have a system that has commingled the concerns of choosing which actions are applicable and the execution of these actions, the rules pattern can also make sense in this scenario. The rules pattern can also be applied if you expect an area of your system to change frequently. Maybe your application supports user-defined rules, and you need to facilitate the ability to import and apply those rules dynamically. In terms of the structure of the rules pattern, it can vary quite a bit. Typically, there is some kind of evaluator class, which references a collection of rule implementations. In the simplest case, every rule is executed and the evaluator examines the results and chooses what to return or what action to take as a result. For instance, in our check system example, the evaluator would hold the logic that determined if any of the rules returned false, rendering the system incompatible. So now that we have an idea of what the rules pattern is, let's walk through an example. I have a computer model that has a couple properties on it, like gigahertz, RAM, disk space, and operating system, and I'm also newing up an evaluator. The evaluator will take our computer model and check to see if any of the properties break any of the rules that we have set in place. So if we go into the evaluate method, we'll see that we're checking to see if the gigahertz is less than 3, if the RAM is less than 4, the disk space is less than 10, and the operating system is not equal to Windows. If any of these are true, the evaluate method will return true, and that'll let us know that there is a property on our computer model that has broken that rule, and our system is now incompatible. So if we go ahead and run this program, give it a quick build, we'll see that currently our disk space rule is broken and that our system is in fact incompatible. And that makes sense because currently our disk space is into 5. So if we go ahead and change it to something like 400, give that another build, and rerun the program, that rule has gone away and our system incompatibility is now set to false. So all of the requirements are met. Now let's say we wanted to add a new rule. We would need to go into our evaluator, find this method, and then we would need to add another conditional here, and let's say water-cooled, set to false. This is basically stating that we want to ensure that the system is water-cooled. Maybe it's a super high-intent game and we need to make sure that the computer won't overheat. And this can just be set to water-cooled rule broken. And this gives us some information to let us know which of the rules were broken. We can go back into our program and rerun this. And currently that rule is now broken and the system is incompatible. But we can go to the store and we can get some new water cooling. And actually that we want to set true. Give that a build. As we can see, our system is no longer incompatible. So that's the old way of doing it. With the rules pattern, we can actually switch over to that by dropping off the old. And I did want to rerun my unit tests. They all passed. And this just gives us confidence that even though we change the entire evaluator class over, that all of our logic is still the same. So if we go into the rules pattern variant, you'll see that the evaluate method is now just one line long. We do have a getRules helper method, and this is basically just loading up all of the rules via reflection, because all of the rules are now placed into individual classes. Now you don't need to use reflection. You could create a generic list of system requirements rule and then new up each of the rules that you wanted, but this is going to require you to add those rules and recompile your application every time you were to add your own rule. You'll see here in a moment that with reflection we can just add the file and not touch any other part of the system. So now that we have that rule in place, let's run the system. And you see that we have the disk space rule, operating system rule, processor rule, and that the system incompatible is set to false. So let's go ahead and add our water-cooled rule using the rules pattern. So that's as simple as adding a new class. We can call it water-cooled rule. Create that class. Just set it to public. And we can just go ahead and take one of the old rules, so they're pretty much all the same. We want to make sure that this inherits from system requirements rule so that reflection can pick it up. That's fine. We want to make sure that the water-cooled property here is set to false, because if it is set to false, we want this to return true, letting us know that the rule broke. Water-cooled rule. Again, just giving us some information. And so all we did was add a class. We didn't touch any part of the evaluator. This is still one line, and we just have our helper method. So now if we run the program, you'll see that we have not only the previous three rules, but we also have this water-cooled rule. And that's set to false, so our incompatibility is set to false. But this just goes to show that even though I added a new rule, I didn't have to change any of the code. It just immediately consumed that and was able to check it against our system. This is a